Pop.
Ow.
All right. So we are talking about the constant of proportionality and writing equations of proportionality and proportional situations. So far we've been working with proportional relationships with tables, with graphs, and now today we're going to focus on both of them and their equations that go with them. Okay. So let's just dive right in. I need us to read this out loud. This is pretty wordy, so we're going to read it twice. So I want you to read it silently to yourself for just a second. Read it silently to yourself, and then I'll read it out loud. Yo, pass it. I don't know what you're doing, but we're on this. Get with us. Okay? Join us. Okay, so the two quantities, listen carefully, this is graphs of proportional relationships. Two quantities, x and y, are proportional, right? We have we've already talked about when x and y are proportional, right? So with tables, when are x and y proportional? Yeah, when on a table, So that was day one, on a table. Yeah, that constant ratio, that's important, that constant ratio. So in a table, if they all have a constant ratio, they're proportional. On a graph, when was it proportional? Passed through the origin and a straight line. Good. And now we're looking at, sometimes we can represent those situations with an equation. So here, we have a proportional relationship when y equals kx. You guys remember when something wasn't proportional on that first day? It was because we added stuff to it, right? It's because we added 120, we added 3, or we added $12 for fuel. In the equation y equals kx, is there any addition? Y equals kx. Is there any addition there? No. What is that? That's multiplication, and that was what we saw. When there was just multiplication, there was proportionality. When we added stuff like that fuel, like the fuel cost for the boat, when we added stuff in, it became not proportional. So if there's an equation that looks like y equals kx with no addition, it's going to be a proportional relationship. Let's look at what the k is. The number k represents that multiplicative relationship, or the value of the ratio, or in other words, the unit rate. Okay? So the constant of proportionality is that value k. And the constant of proportionality is sometimes called the unit rate. You guys remember how we get the unit rate? Yeah, we use division. Well, here's why k is called the unit rate. So if you have this equation, y equals kx. If you have that equation, what can I do to get k by itself? Can we pretend that that's the variable we're going to solve for? What do I need to do to both sides to get k by itself? Divide. I need to divide both sides by x. X's on the right side are going to cancel. And I'm left with y over x equals k. Well, hey, y over x? What is that? Is that a division of two numbers?
Yes.
Is that a ratio?
Yes.
Yes, that would be our unit rate. So this is y. This is the equation, y equals kx, that's going to represent a proportional relationship. That is going to be our proportionality equation. Why does it work? Well, because k is that unit rate, or constant of proportionality. Why? Because to get k, how do you find it? You divide the y values by the x values. You're checking the unit rate, right? You're checking to see if there's that constant ratio from tables. Or you're looking at a graph and you're looking at the y value and dividing it by the x value. We talked about it very briefly yesterday, just a little bit, right? So that's what k is. K is the constant of proportionality, or the unit rate. If we have an equation, y equals kx, you have a space on the right side of your notes. Maybe write that equation a little bit bigger. You have a space on the right side next to that graph. Next to this graph, you have a space. Maybe write y equals kx. Just a big one, so you have it. That's our big equation. So if something is proportional, we can write this equation, where k is the constant of proportionality, or the unit rate. Let's dive right in. You have your calculators in front of you, so you should be able to instantly tell me if this relationship is proportional. So check using your calculator or using your, you can just look sometimes. Sometimes you can just look at it. If you can't just look, sometimes you just have to do the division, right? So is this proportional or not?
Yes.
Yes, it is. Yes, this is a proportional relationship. Why? Because 4 over 1, 8 over 2, 12 over 3, 16 over 4. Why did I do it that way? Why did I not do 1 over 4, 2 over 8, 3 over 12, and 4 over 16? What did we just look at? Well, if I go back one slide, what did we just look at? Y over x. We want y to go over x. And I have shared with you in the past just once that time is always the x value. X. This will be y. Because what is distance over time? Anybody know what that's called? It's speed. It's a rate. It's a rate of speed. Distance over time. So I did distance over time. And those all simplified to 4, right? All those ratios simplified to 4? So, what is our constant of proportionality? What's our unit rate? With units, what's our unit rate? 4. No, not 4 over 1. That's too mathy. I love that idea. That's the math answer. But we're talking real world. So what's our real world unit rate? 4
inches per second.
Boom, nice. 4 inches per second. And now what would our equation be? Well, keep in mind, what is our equation? What is the equation you wrote down up at the top of your notes? Y equals kx. Well, what's k? K is our... What does it say in that box of information? K is the what?
A number.
No. No. Come on, guys. K is the...
Unit rate.
Or the... Okay. So, write our equation. What would our equation be? Y equals 4x. That's our equation. Because what is K? K is our constant proportionality, or our unit rate. So Y equals Kx. How far would he travel in 10 seconds? Seconds is the X or the Y value? Is the X. So 4 times 10 is? So how far would he travel in 10 seconds? That's where this equation can be helpful for us. Okay, let's do the next one. Use calculators, determine. Notice it's Y cost, minutes are X. Notice, so what should you be doing? What should we be checking? Should we be checking 500 over 40 or 40 over 500? 40 over 500.
It's not proportional.
It is not, you can tell right away. So, we're done. Our equation, y equals kx, is the equation for what kind of relationships?
Proportional.
Good, so if it's not proportional, are we going to use that equation?
No.
No, done on that problem.
Number 3 is proportional, so you
Okay.
gotta work on that one now.
Questions on that? So if you get it that it's not proportional, you don't do anything. Let's do number 3. Proportional or not proportional? I bet we can look at it and tell. It is proportional. Let's find our constant. Now, how do we find our unit rate? Well, y over x equals k. So k is our constant, right? So we need to do y over x. So you can just pick any of those points. Which point do you want to pick? 2, 11. So this is the x value, and this is the y value. So what is my unit rate? How do you find it? Well, you would do 11 over 2, which equals 5.5. Now, what are our units here? Y over x. What are our y units? Feet. And what are our x units? Seconds. Feet per second. Questions on what I just did? How did I get 11 and 2? I picked a point. Where did the 11 come from? the y value. Where did the 2 come from? X value. And then I just did my division, right? Because isn't that the unit rate? How do you find the unit rate? You just divide, right? Now what is our equation going to be? Well, there's 2 ways you can write this equation. Y equals, or if you wanted to leave it as a fraction, you can. You can also have y equals 11 over 2x. Either of those is acceptable. So if you didn't want to simplify this to 5.5 feet per second for your equation, you didn't have to. So either one of those is acceptable. Questions on this problem? Yes, sir?
I thought you said time would always be x.
It is. So time is 2, so we use this point. So x is time, y is distance. Y over x is our constant proportionality. So we had 11 over 2.
But when we write it, we don't put 2 over 11.
No, because our constant proportionality is y over x. So did you write down the equation with me to figure out what k was? Here, we were determining what k was. K was our constant proportionality. How did we get k by itself? We had to divide by x. You see that? So x will be on the denominator. This is number 4. This is the last problem that we'll do here until we flip over to the back. Tell whether it's proportional or not. Is it proportional?
Yes.
Yes,
That's
good.
the origin.
What is the constant of proportionality? Well, pick a point and go with it. Which point do you want to pick?
0, 0.
1.3.
0.
So let's think strategically. Could you pick this one?
Yeah.
Yes, you could. Could you pick this one?
No.
No, because you can't divide by 0. Should we pick that one?
Yes.
Why?
Because it's the smallest number. No,
That's true,
you
but
divide it by-
what's this point? What does this point represent? Well, it says that for every 1.5 inches, it takes 1 second. So why is that the easiest point to pick?
Because it's 0.5, you can just turn it. Wait, never.
Actually,
That's your unit rate?
that's our unit rate. It's something over 1, right? Isn't a unit rate over 1?
Oh.
So if you have the option for this point, boom, pick it. It makes it a lot easier because it's already over 1. So our constant would be 1.5 over 1, which equals 1.5 inches per second. Now, could we have picked this point?
Yeah.
Absolutely. You would have done 4.5 over 3, and that would simplify to 1.5 as well, right? So it doesn't matter which point you pick, but if you have the option for this one, you can just look at it and know. It's kind of nice. What's our equation then? Y equals 1.5x. Cool. So that's all the problems we're going to do with writing the equation. Now let's use the equation, okay? So we got some word problems on the back. 3 different kinds, right? One with the graph, one with the table, and one without either. So I'm going to ask you guys to be doing a little bit more now. First thing we need to do is find the unit rate from the problem. It's going to be given to us somehow. The second thing is, we write our equation, y equals kx, where k is the unit rate. Or what else? What's it also called? Unit rate is also called constant of proportionality. Now, Desi isn't wrong. When we were talking earlier about what makes something proportional in a table, it had to have a constant ratio. And so today we're just giving that ratio a name. It's called a constant of proportionality, or the unit rate. And then we're going to use the equation. We're going to use the equation by plugging in for x. That's just how it's going to work. We're going to plug in for x. So here's our situation. We've got a table here. All right, Maddie, read this problem out loud for us.
The table shows the profit y for recycling x pounds of aluminum. Write an equation relating to the profit to the amount of aluminum. What is the profit for recycling 75 pounds of aluminum?
Good. So there's actually 2 things to do here. What's the first thing to do here?
First, you guys see how much it costs for 75 pounds.
Nope, that's actually the second thing to do.
Oh.
What's it tell us to do first? Is it Lolly?
Find
Well, actually, it doesn't tell us to specifically do that. That's what we're going to need to do. You're absolutely right. We're going to need to do that. But what does it tell us to do? Good. Relating profit, which is what? Y, money. Profit to aluminum, which is x. So we need to write an equation relating y to x. Well, That's our y equals kx equation, right? Y equals kx. So, what do we need to find? So Lolly told us, what do we need to do? Find the unit rate. So, find the unit rate. Use your calculator. Figure it out. First off, is it proportional?
Yes.
Is it?
Yeah.
You can always just check by doing division. Just do the division, right, on your calculator. What should you be dividing? Should we be doing 10 divided by this? No, unit rate is the same thing as unit price. It should be 4.5 over 10, 9 over 20, 13.5 over 30, and 18 over 40. And are those all equal? Yes, they are. What is our unit rate then? Pick one. Pick one of these to do.
9 over 20.
I don't care. Sure. 9 over 20. Just do it in a calculator. $9 over 20 pounds equals what?
0.45.
$0.45 per pound. So what's our equation going to be? So y equals 0.45x. So that's the answer to the first part of this question, right? It says write an equation for it. Now, how do we do the second part? Well, what does x represent in this problem? Yeah, x is the pounds of aluminum. What is the profit? So we're looking for y, and we know x. Right, we're looking for y. What is the profit, y? If we know x, well, what's x in this problem?
Aluminum.
Yes, that's true. What is x specifically in this last part of the question? Be specific. 75 pounds. So to answer the question, we would say y equals 0.45, plug in 75 pounds, and what do we get?
33.75.
What is it?
33.7.
So it'd be 33.75. That is the profit. So the interpretation part of this question is saying, all right, what are we looking for? Are we looking for y or x? What are we given? Are we given y or x? And then we just have to plug into the equation. Most of the time we're going to be given x. I'll tell you most of the time. So that's how we do it with tables. With tables, we just find the unit rate, like Ollie said, write the equation with the unit rate, or constant proportionality. Then we plug in our number, plug in the question that's there, and then you can solve.
Did it have to be proportional?
In order to use this equation, it must be proportional.
All right.
Could we have also solved this with a proportion? We could have also written it like this. I'm going to write it up at the top right. We could have also written 10 over 4.5 is equal to 75 over x. What's the 10 represent? Yeah, the aluminum. What's the 4.5 represent? The cost. So what's the 75 represent? The actual amount, and then x would be the thing we don't know, right? We could have also written a proportion for that. So the equation is just specifically to proportionality. All right, let's do it with the graph. We'll go a lot faster here now that we kind of know what we're doing. So let's answer the first question. Is the number of tickets proportional to the cost?
Yeah.
It
113.
is proportional. Why?
They all equal up to 113.
No. Why?
Oh, because that's proportional.
Straight line.
And oranges.
Straight line through the origin. Good. Straight line through the origin. Now we want to write an equation that represents this situation. So we need to just pick a point. Which point do you want to pick?
565.
Let's pick this one, just because. So I need to find the unit rate. What is the unit rate from this? $13 per ticket. So what's my equation going to be?
Oh, y equals 13.
Y equals 13x. Now, use our equation to find the cost of 14 tickets. Why do you need an equation to find the cost of 14 tickets? Well, because 14 is not on the graph, is it? So, what's the cost of 14 tickets?
$32.
How'd you get that?
I had 13.
Exactly, and we got Y equals how much?
182.
$182. How did we find the unit rate? If you haven't written it down by now, you probably should have written it down how to find the unit rate. How do you find the unit rate?
You divide
What?
the cost of 14 tickets, so 182 divided by 14.
No? That's one way to find the unit rate. The y divided by the x. So just pick one of these and divide y by x and you're fine. Okay? All right, this time we don't have a table or a graph. So we gotta figure out how to find the unit rate. Right? Isn't that our first step to do? Find the unit rate. Nina charges $34.50 for 6 days of pet sitting. Write an equation relating the cost of pet sitting, notice the order, cost of pet sitting, to the number of days. Cost to days, so it'd be cost over days. Right? So how are we gonna use that idea to find our unit rate? Cost per days would be
34.3
over 6.
6.
So what's our unit rate? Use your calculator. 575?
Yeah.
Okay. 75 cents per day. Now we need to write an equation, right? Y then equals what? 575x. So then answer the question. 4. So y equals what? What's the cost for 4 days?
$23.
$23. Questions? The last question you guys are going to do all on your own, the entire thing. Okay? With your partner, of course. So, Jane babysat for 4 hours and made $22. You're going to create a table, graph the situation, identify the constant proportionality, write an equation, and then answer the question. With the people around you. So, you've got the situation, start graphing, there you go. Start putting the information in a table, create a table for the situation. Okay? Go. All right, there it all is. So I decided to go down to 2 and 11 because I wanted to see if I could get it closer to the origin. This isn't the only numbers that come on the table. How many people did 4, 8, 12, and 16? Yeah? Anybody do the division? Anybody go figure out what the 1 was? 1 was 5.5, then 2. Anybody do that? Anybody figure out the constant proportionality right away? That's cool. You can do that. Constant proportionality of this case, of this problem, was $5.50 per hour. So our equation y equals 5.5x. So how long would she work in a 40-hour work week? 5.5 times 40. Good to go. All right.